Okay, so the question that we have been given here, this is also an extension of how they bring questions under concentration and molarity. So they're saying that 0.15 molar of sulfuric acid was reacted with sodium hydroxide. Okay, and then the question is as follows: given that the volume of the acid and the base are 20 centimeters cubed and 25 centimeters cubed respectively, calculate the molarity of the base. So molarity concentration can be further extended to acid-base reactions. So by now, I'm sure we all know that anytime an acid and a base are reacting, such kind of a reaction is a neutralization reaction. And the formula that we use anytime we are relating the molarities and volumes of acids and bases is Na over Nb is equal to MaVa is equal to MbVb. Now, this should not be mistaken for the dilution formula that we had seen in the previous video. The dilution formula, if you recall, this formula was given to be M1 V1 is equal to M2 V2. That was our dilution formula. But this one, on the other hand, is Na over Nb is equal to MaVa over MbVb. So Na is just number of moles of the acid. Nb is the number of moles of the base. Ma is the molarity of the acid. Va is the volume of the acid. Mb is the molarity of the base. And Vb, lastly, is also the volume of the base here. So it's important that someone understands these notations very carefully. Now, of course, it's easy for us to plug in our values for the molarity of the acid, volume of the acid, molarity of the base, the volume of the base. Challenges, however, might come to trying to substitute the values for Na and Nb. Na, these are the number of moles of the acid, like we have said, and Nb, this is just the number of moles of the base. But one thing that we need to understand is that Na and Nb are coefficients of your acids and bases. Na and Nb are stoichiometric coefficients of your acid and your base, which means that it's very much important that before anything has even been done, someone should determine or someone should write a balanced chemical equation for that reaction. Like a good example, if we notice sulfuric acid was reacting with sodium hydroxide. Anytime a neutralization reaction is taking place, we always produce a salt and water. They are neutral, that is, they have a neutral pH. That's the whole reason why it's even termed as a neutralization reaction, because the products formed have a neutral pH. Sulfuric acid is H2SO4, sodium hydroxide, that has already been seen, our sodium sulfate and our water are being produced. These coefficients that we put here, like the sulfuric acid is having a 1 even though they haven't shown it. The sodium hydroxide is having a 2. Sodium sulfate is having a 1 even though they haven't shown it. These coefficients are what are termed as your stoichiometric coefficients. Thus, when you are trying to substitute your values for Na and Nb, we just get the coefficients of the acid and the base. It's very much important that you know how to balance your chemical equations. So if you notice, we are having sulfuric acid here. Sulfuric acid has a stoichiometric coefficient of 1. That's the whole reason why on Na we're just putting a direct 1 there. Nb, that's the stoichiometric coefficient of the base. Our base is sodium hydroxide and it is having a coefficient of 2. That's the whole reason why you are seeing a 2 there. Ma is just the molarity of the acid, which is 0.15 molar as seen. That's the whole reason why on Ma we're just putting 0.15. Okay? The volume of the acid here, according to the question, is going to be 20 centimeters cubed. There is no need for you to start making conversions again, just like we had said on the dilution formula. There is no need for you to start making conversions. That is, you begin to convert your volume values from 20 centimeters cubed or 25 centimeters cubed to decimeters cubed here. Just plug in your values directly and everything is going to work. So this is going to be 0.15 times 20. The molarity of the base is what you're trying to solve. That's what you're looking for. That's the whole reason why we're just leaving it unchanged. That's the whole reason why it's just like MB present like that. The molarity, or rather the volume of the base, according to the question, this is the 25 centimeters cubed that we're seeing here. So that's the 25 that we're seeing here. If we multiply 0.15 times 20, this is just the 3 that we're having here. MB times 25, this is 25 MB. 1 over 2, unchanged, like that. Upon doing that, you can cross multiply. That is, your 2 is going to be multiplied with your 3. That's where the 6 is coming from. 1 multiplied by your 25 MB. This is just the 25 MB that we're seeing here. So I brought this problem this side. So 25 MB will be equal to 6. And of course, if we do our arithmetics or evaluations, you're going to see that the molarity of the base is just going to be 0.24. Okay, the molarity of the base is just going to be 0.24. So if you see that the mole ratio or the stoichiometric coefficients of the acid and the base are different, it's okay. You can use your Na over Nb is equal to MaVa over MbVb. But let's take, for instance, maybe say you were reacting, maybe say hydrochloric acid. Hydrochloric acid was being reacted with sodium hydroxide. When hydrochloric acid is reacted with sodium hydroxide, our products here are going to be sodium chloride. Sodium chloride plus water, which is just going to be H2O, like this. So, if we look at it, on our reactant side, there are 2 hydrogens, just as we are having 2 hydrogens on the product side. There is 1 sodium, 1 sodium, 1 chlorine, 1 chlorine, a single oxygen there, a single oxygen there. So for problems like this, you're going to see that the equation is already balanced. In other words, your Na is equal to your Nb, and that is going to be equal to what? Equal to 1. Because our acid here is hydrochloric acid. It's just 1. That's the stoichiometric coefficient. The sodium hydroxide as well is just having a 1. So if you see that the mole ratio is the same, or the stoichiometric coefficients are the same, 1, 1, then instead of writing Na over Nb is equal to MaVa over MbVb, this one can just be shortened to MaVa is equal to MbVb. You can shorten it in this way. Why? Because the stoichiometric coefficients of the acid and the base are the same. So if you see, they're like 1 to 1, 2 to 2, 3 to 3, whatever. If you just see that the values in front there, the coefficients of the acid and the base, if you just see that they are the same, we can restrict it to MaVa is equal to MbVb. But again, never confusing this formula with this one. M1V1 is equal to M2V2. Ma is the molarity of the acid. Va is the volume of the acid. Mb is the molarity of the base. Vb is the volume of the base. M1 is the initial molarity. V1 is the initial volume. M2 is the final molarity. V2 is the final volume. We use this formula when you're talking about a single thing. Like in the previous video, we were strictly talking about sodium hydroxide. it was sodium hydroxide that was having an initial molarity, an initial volume, final molarity, final volume. We're just talking about a single thing. But in this formula, MAVA is equal to MBVB. We're not talking about a single thing. We're talking about two things here. We're talking about an acid and a base. Molarity of the acid, volume of the acid is equal to molarity of the base, volume of the base. So don't try to mistake these two formulas to be equal. This one is applied only to acid-base reactions, provided that maybe something has been given, some data has been given on the acid and maybe partly for the base, and then you're being asked maybe to say find the volume of the base. That's when you can use this formula. This one is only used in cases where you are diluting or concentrating something. This is the whole reason why I'm just calling it briefly as a dilution formula. So this is how molarity and concentration concepts can be applied to acid-base reactions. So the key thing is that someone needs to understand this formula. Na over Nb is equal to MaVa over MbVb, where Na and Nb are just stoichiometric coefficients of your acid and your base, and your MaVa, molarity of acid, volume of acid. MbVb, that's just going to be your molarity of the base and the volume of the base. So that's it.